Our next speaker is another member of the IATMO Green Technical Committee. Bob Boulware is the founder and president of Design Air Engineering, a mechanical, electrical, energy consulting engineering firm specializing in providing solutions for off-grid mechanical electrical needs, energy-related retrofit of building mechanical and electrical systems, LEED certified structures design, and assisting clients to obtain financial assistance to upgrade inefficient mechanical and electrical systems. Bob received his BS in mechanical engineering from Purdue University and his MBA from Indiana University. He is presently the 2011-2012 National President of the American Rainwater Catchment Systems Association and an accredited rainwater systems design professional. He is a life member of ASHRAE and of ASPE. He's past president of the Central Indiana chapter of ASPE and serves on the ASPE National Standards Committee. He's a registered professional engineer in 30 states and the U.S. Virgin Islands. Bob's latest publication, Alternative Water Sources and Waste Management, is scheduled to be published in the third quarter of 2012. Bob, the podium is yours.
Thank you. Some of you people have been around long as I have will recognize this is basically a shameless reference to a 1960s protest song about war. Rainwater, what is it good for? Everything, absolutely everything. And we'll talk more about war later. What we're going to talk about is water availability versus the population trends, where we're at right now, and what's our expectation is going forward. And we're going to basically introduce the concept of as an alternative water sources, specifically rainwater collection and also stormwater management as a better way of managing the aquifer and maybe improving situations that we have right now. And add our voice to making people aware of the need for better water management all the way around, and to help encourage IATMO to consider other alternative water sources beyond rainwater catchment, condensate reclaim, cloud harvesting, dew collection, things like that that are out there that are new to most people, but certainly something to consider going down the road as the situation and the need becomes more apparent. And we also want to talk about protecting the water sources that we have. This is old news. I think we're seeing the population, obviously, of the world is increasing, but more importantly, the water demand is increasing. You can see down at the bottom of the red line, the Australians, they just recently, and I think to some degree continue to manage with a drought situation they have out there. And one of the benefits of the drought that I've heard about is that they have increased the use of rainwater catchment, and they've got standards out that are becoming, making rainwater quite popular. As you go up the ladder there to the Western countries, you can see that the water is trending upward, but maybe not so radical. The alarming line is the black line, which is Asia, as the people become more apparent or more affluent. In Asia, they're wanting what we have, and they're basically consuming more water in the process. So all up, you can see the blue line, we have a significant increase of water expectancy around the world. This is a water stress map. The UN basically right now is saying that 1 in 5 lack safe drinking water. We've heard that before. They're projecting that the per capita water availability will drop 30% in the next 20 years. Bill Hoffman talked about and alluded to the fact that we have the same amount of water that we had back when the dinosaurs. It's just we have more people to share it with. So as a result, the per capita needs are going to be dropping as we move forward. Currently, about 20% of the world right now, as we speak, are under water stress, with approximately 8% perilously close to that threshold. And if you factor in pollution going forward, we may be in a situation where 65% of the world here in the next 20 years is going to be in a water stress situation. In North Africa, from North Africa to China, to Asia, The allotment of the world water is 1 to 2%. In the U.S., we're blessed that we're going to have 5 to 10% of the world water. So it may be looking forward that we should be prepared to take in borders as people look to find other sources of water. Interesting, a new concept is that and water shortages are basically a slippery slope into food shortages. This August, there's an interesting seminar in Stockholm about energy, water, and food security. That's a new concept, but if you think about it, water shortages definitely lead to food shortages. It takes 1,000 tons of water to make a ton of grain, and if you're looking at the North Africa people there, if you project what they import, the easiest way to import water is to import your food if you can't grow it yourself. But what they would expect to import would equal about half of what the U.S. total grain population would be. So something that in itself is not sustainable. So unless there's action taken, I think we can anticipate that there's going to be trouble ahead. We mentioned war. This was the article that Dr. Jones referred to that was published back in March. The worrisome thing is that the U.S. intelligence is pretty sure there's not going to be a war about water in the next 10 years. But beyond that, they're not very clear on that. And it depends on what individual states do and what actions are taken right now to work to water management issues between the states. I think the government, as we kind of find out, is a little bit dysfunctional. So I think if there's any action to be taken, I think you can look around this room, and I think we've got the right people. If it's going to happen from people in this room. U.S. drought, this is something you can get monthly, update on what the situation is right now. This is April 3rd, fairly recent. And you can see that Texas is needing some rain down their way as pretty much the bottom part of the country. But the interesting thing is up in the upper plains, some of the crop growing areas, they're also having a little bit shortage of water. Long term, the bottom third, bottom half of the country is looking to have water shortages. So definitely there's a need for alternative water. 95% of the water for Las Vegas, as we learned, comes from Lake Mead, and obviously that's a declining asset. 95% also of the water, the fresh water, is groundwater in this country, commonly accessed by wells. And as we pump more and more wells, the water table drops, leading to dry wells. Bill Hoffman also mentioned about land subsidence, where you actually get the ground settling. In Florida, you've commonly seen sinkholes where the water is pulled out. And basically the water, by removing it, the soil loses its suspension and starts to collapse. And there's a theory that perhaps some of the rising in the ocean is due to the fact that it's a combination of land subsidence from pumping the water out, and the fact we're taking all the water in the land and eventually pumping it into the ocean. It basically, with increased deeper wells, we're talking about more pumping horsepower required, more energy involved. We talked about earlier, we're almost 30% of some western states. Marianne Dickinson talked about the energy required to pump water out of the ground. Near the coast, you're getting at water quality issues with the saltwater intrusion. If you're in the valley, a wine-growing country of California, the deeper wells there are bringing up boron in the water, which is basically contaminating their ability of making a quality wine, because the quality of the water isn't. And they're looking at rainwater catchment out there as part of their product. And you have rivers and streams in the process. So as you're below the water table, the streams and rivers will dry up. This is a picture of Tucson, Arizona. Back in 1904, the water table was 40 feet below the water. They had a couple of guys with the burro that would sell water at the outrageous price of 5 cents a bucket. And the people got up in arms about that, had the city fathers put in a pumping system and started pumping the water. And that's when the water table started to drop. And there you see the picture up in the upper right, that the Santa Cruz River, which runs down the middle of Tucson, is pretty much dried up. It's as the water table is dropped, it pretty much is used as a storm ditch right now. One of the other things you might note is the upper left and the bottom left is deciduous trees. As the water table has dropped, since the root balls of the deciduous trees only go down so far, all of a sudden they've died away, and you're left with the scrub stuff that you see on the right pictures. So declining water table is a problem. Certainly if you're looking at the Ogallala Aquifer, where you have 20% of the people, 20% of the irrigated land of the country is in this area that goes from Texas up to North Dakota. This is fossil water, they call it. It's basically land that was, water that was deposited back in dinosaur times, and it's, people tell me that it's being depleted about 10% a year. This is water that can't be replenished in our lifetime. So once it's gone, it cannot be replaced. Water tables are dropping pretty much around the country. This is Atlanta. You can see the trend there. This is Chicago. It's dropped 16 feet in the last 10 years, 900 feet since 1864. And this is right next to Lake Michigan. And in Texas, they have a similar problem with a declining water table. People in India basically have had this problem for several years, and this is where we're going to talk later about what we can do to stormwater to maybe help slow this process down. We've talked about the water, or the water that's used to make energy, and this is the energy it takes to make water. You can see that the well water, if you got well water, that's the lowest energy, somewhere about 1.5 kW per 1,000 gallons. But it trends up radically according to how much, what the level of pollution is. Certainly, if you're talking desalination, as they have in coastal cities in California and Florida, it gets quite expensive and quite energy intensive. Certainly at the 12 kW and the associated price, unless it's heavily subsidized, is not something that you'd really want to water your lawn with over a long period of time. So what are the choices? Well, generally, municipal water, it's available year-round. It's a pretty good asset. It's cheap in the short term. Long term, we're not real clear on what the availability is, and possible disruption during emergencies. We have an option of municipally provided recycled water, which Rob talked to us a little bit about. It's not available everywhere, but it is available in some parts of the country. But it requires safeguards from the potable water system, as any alternative water system would, and as we've learned, may have some maintenance requirements associated with it. Greywater, again, available on site, expensive first cost, but usually has a decent payback when you're talking about reducing 75, 85% of your water supply. It serves to buffer the combined sewer overflows, which is an issue. But why not consider rainwater catchment? Everybody's familiar with the water cycle. The customary way of getting your water is you kind of pick it up on the ground, or you dig it out of the ground as it's accumulated a lot of the pollution from the byproducts of agriculture, street debris, things like that. And we put a lot of energy and a lot of chemical in to take all this stuff out. The people that are promoting rainwater, they like to kind of get it at the source as it falls out of the sky and treat it much more, less energy intense than what goes on at the municipal plant. We're all familiar with this graph here, and essentially the takeaway on this is that about 80% of the water in an average household doesn't really need to be potable water, high-grade, utility-grade water. It can be done with minimally treated, what they call fit-for-purpose water, which would include rainwater. In a commercial setting, this is a typical breakout of water. You wouldn't want to apply it everywhere. The restaurant where you have a high need for potable water, perhaps you wouldn't want to have rainwater catchment. In office buildings, I think you definitely could make an argument for it. That little red line is the potable water requirement. In an office building, if you go to the Virgin Islands, it's very often that all the water there, it's required to have rainwater catchment as part of their construction costs or construction procedures. And if you want potable water, they'll maybe have bottled water there in the hallway there for you to get a cup of. And the other things, you can pick your positions. In schools, you can certainly have restrooms to flush. You got your irrigation and perhaps even hospitals, maybe laundries with a laundry using rainwater catchment. You'd have the side benefit of using, since it's soft water, you would use a lot less detergent and therefore less pollution into the sewage stream. There's guidelines that are started out. One of the early best ones was the Texas Manual on Rainwater Harvesting. This was developed with the help of one of ARCS's early vice presidents, Dr. Dennis Lai, who's a microbiologist with EPA out of Cincinnati. So a lot of the good ideas, we borrowed from that. We borrowed from the Australians, New Zealand, Germany. We were shameless about taking every good idea we could come up with around rainwater, and that developed the document you see on the right there, the Rainwater Catchment Design and Installation Standard, which we're working with ASPE to try to achieve ANSI status for that. This document then was a source document to these documents that we're more familiar with the water quality issues that are in the Green Plumbing Supplement are issues that we basically took out of the ARCSA manual, which again we borrowed out of the Texas manual, which are the same standards that are used in the UK and Australia for maintaining water quality suitable for flushing toilets. It's the same, what they arrived at it's the same quality water that you can take your family to the beach and splash and swim with your kids. And if the theory is if it's good enough for you and your family to go swimming in, it's probably good enough that you can flush your toilets with it. Rainwater systems are fairly simple. You just need a decent collection surface. The best is either a membrane roof. You can get NSF quality membrane roofs. If you're in a sloped roof, galvalume is usually the best. Tile roofs are good. Not so good, but you can use them as galvanized roofing and even shingle roofs if it's properly has the roof wash, the pre-wash taken care of. Although there's a lot that I disagree with in the speaker last year, the microbiologist, what I do agree is the necessity to maintain clean water going into the tank. If you get a lot of debris into the bottom of the tank, it'll sit there and it'll basically ferment and it'll cause what they call aerobic digestion, which is what goes on in an outhouse. The byproducts of combustion are basically, or byproducts of the fermentation process are SO2, methane, and a lot of other smelly gases. So what we basically say is, okay, it's best to keep the water clean going in. That big tank going at the bottom is a roof wash system mechanism, and we'll talk a little bit about that later. It's important that the tank be impervious to sunlight. If the sun gets in, those clear kind of milky white tanks are not a good idea because when the sun gets in, you'll basically have algae growing in them. To that same problem, the air vents, the overflows, all want to have bug screens in and have basically an indirect attachment to the tank, again, to keep light from coming in and causing problems. To the microbiologist's point, it's also a good idea not to put the tank in the sun, particularly if it's dark. If it's dark, to keep the sun in, it's going to generate a lot of heat if you put it in the sun. And as you start approaching 100 degrees, then you're on your way to creating a lot of biologicals, Legionella being one of them. So there's some things that you need to do to kind of provide a good system, but they're all manageable. Backing up on your roof system, one of the things that you wouldn't want to use is some of the biocide impregnated roof shingles that are used to get the moss and the mold off your roof. If it's going to kill that, it's probably you wouldn't really want to use it for your plants because it'll probably kill those as well. So those are a no-no, but all else can be done with the proper care and management. I mentioned pre-treatment. It's kind of important. You want the leaves off. This is probably your grandfather's pre-treatment, the simplest of the systems where you basically it rains for a little bit, you turn the valve, and then it goes into your tank. More automated version of that is it's kind of a dead-end pipe situation where you go in and you basically, the early rain event basically goes into this tank, this or blind piece of pipe. And the thought is that any debris on your roof then will wash off up to the point, and then it'll overflow and go into your cistern. This is a state-of-the-art filter. This is a WISI filter marketed by J.R. Smith. It has a centrifugal filter that allows, there's a mesh screen the water goes through, and when it's dry, it lets the water just go straight on through along with the leaves and the debris off your roof. And then when that mesh screen, I think it's about a 20 mesh screen, when it gets wet, the capillary action then allows the water to go into your tank, and that's the pipe going off to the left there. Works very well. So what about rainwater quality? That's usually what people are concerned about most. This is the water quality report from my hometown, Indianapolis. I'd like to direct you to the website there at the bottom of the page. You could copy that down, and you can check the water in your own hometown. Typically, I usually do this from all the places I visit. And they have these little black squares and yellow squares and red squares where it basically exceeds the safe pollutant levels. And you can see in Indianapolis, they had 25 events in the last year with some barium, agriculture pollutants are pretty common, industrial pollutants. And these are the things that are monitored. And again, I would encourage you to check your own water. What isn't monitored are contaminants. Rob mentioned the pharmaceuticals and such that are in the water that are causing problems with frogs and fish and things like that. A couple days ago, I had a very alarming situation. I was talking to a lady who is a beautician, and I asked her how business was. She said, well, it's pretty busy with all the girls coming in getting ready for the prom. He says, one of the biggest things that they do, and she has several girls come in wanting their beards taken off. And I think, man, that is weird. So yeah, what's in your water, what's in your food supply, it's grounds for concern these days. Got a good friend, John Hammerstrom. He lives in Key Largo, Florida, and he lives in the rainwater catchment system, very proud of his water system. He has it tested from time to time, and he likes to brag a lot about it. You can see, as you go down there, that second column says ND is none detected. Some of the calcium that you'll see in there is basically he has a concrete tank, and the rainwater will leach into the water, which is a good thing. It needs a little flavor, and it serves to buffer the pH a little bit by absorbing the calcium. It goes on down, and there's really nothing in it. In the bottom right, you see a lot of things with a lot of long names. If you go to a municipal water supply, you'll see a lot of those. Those are typically byproducts of the water purification process. The interesting thing, there was an article I just read last week about with the chloramines being put in, they add ammonia to treat the chlorine-resistant stuff, and the chloramines created are now causing problems with copper pipe. Again, water quality. As I mentioned, the water quality that the ARCSA people developed with Dennis Lai is this. This is the water quality that we proposed to the Green Plumbing Supplement, and you can see there's a table in the Green Plumbing Supplement that refers to this water quality. And as I mentioned, this is swimming water quality that you can swim in, therefore you should be able to flush your toilet. And if you go through the care of the pre-wash and maintaining the quality of the water going in, it's very easily maintained. Brad Pitt, with all the best intentions of the world, contributed a bunch of rainwater catchment systems to the city of New Orleans. The care was not as diligent with those that no one knew, and they basically were the worst case scenario, where all of a sudden the sun got in, they grew algae, they bred mosquitoes, the water wasn't clean, so it created a bad situation, so much so that the city of New Orleans basically came in and red tagged all the systems, and you now no longer can have rainwater catchment in New Orleans. One of the things that you can write a standard, but okay, how are you going to maintain it? And that's one thing that we've done for a non-potable situation. Every 12 months you have to have it tested. These are private systems, of course, so you put the onus on the owner to check his system and make sure that it's right. On the potable side, there's another table in the Appendix B that basically says that you have 0 for all the protozoan cysts and things like that. We had 0 down there and had a microbiologist jump up and say, well, there's no such thing as 0 in the biology world. It's just basically percentage of reduction. So it basically is a matter of 1 9 or 2 9s or 3 9s of reduction to get potable water. Because this is a little bit more serious, the code, IAPMO and also ARCSA are recommending that this be monitored every 3 months to make sure that, that these things are maintained potable. John Hammerstrom does his every year, and it's just a matter of maintaining the system. What John does is you have a system like down the blue system down the bottom. You start out with a 20 micron. You go down to 5. Typically, John takes it down to 1 micron. And what you want to do is that one on the left is the ultraviolet. And what you want to do is basically have your water clean enough that there's no particles that shade the bacteria as it's going through the water. So it gets exposure to the water and therefore kills the it basically kills bacteria. It will kind of immobilize cysts and giardia and cryptosporidium, which chlorine won't address. So UV is fairly inexpensive. They have like point of use things in the upper left. The upper right is more of an industrial grade. Atlantic Ultraviolet does a very nice job where they got a little plunger there. You got to run it back and forth to take the biofilm off that accumulates on the glass tube that surrounds the UV lamp in order to keep the UV working properly. Stormwater, I'll just briefly go through that. As I mentioned, India basically is taking the water that normally would go into the river and putting it into the aquifer. And they are seeing results. Dry rivers are now starting to flow. Typically we see it's kind of the flip side of rainwater catchment. You'll see that we have a lot of paved parking lot, and we want to get away from the point of just putting in a bigger pipe. Brad Lancaster is basically promoting a lot of let's put the water onto the site, and then only if it overflows, let's let it do some work before it goes into the sewer. What they're promoting is basically pervious parking lots, rain gardens, let the water in the aquifer. Benefits are that you can grow more trees, less cooling required, less power for air conditioning, less water needed to make electricity, and then less electricity to make the water. And the benefit's kind of a win all the way around with energy, water, infrastructure, and a money savings. Examples, if you go to all that nice roof is collection surfaces in high-end neighborhood in Hawaii. You have rainwater collection. It's basically hidden behind the hyacinths there, or hydrangeas. This is in Panama, where they have solar on shingles on there, rainwater collection, composting toilets, and that nice garden is actually to aid the leach field performance. It goes beyond just decoration. This is a place that's offline. It's off-grid rather. It has solar shingles, rainwater catchment, composting toilets, but it has high-speed internet. It's in and on an island in Bocas del Toro, Panama. This is the Hilo post office with the rainwater catchment. This is in Hawaii, and I ask a naive question, why don't you just run a water pipe? I say, well, we're on a volcano. We dig into the ground. We're in the volcano. This is an application where they collect the water off a greenhouse. The big pipe goes into the ground. Over the right, that pipe goes into this retention pond created just by depression with a pond liner. It then is pumped with a low-pressure pump, shallow well pump, and then you see those small lines around the bottom of the thing that are then irrigation to water their violets that they grow in there. This is Lopez Island School. They had a situation that's up in Pacific Northwest where they had saltwater encroachment. So they basically put in a rainwater system, 1.5 million gallons per year. They use basically chlorine, ozone, and UV. They basically, because there's kids involved and this was new to them, they pulled out all the stops on water treatment. So what do we do? Well, I think we're calling for just better water management. Let's don't let it erode the sewer. Let's do like they do in Europe and they're doing in India. Let's go into a tank where we can pull out of the water, we can water our lawn, we can flush our toilets. And this is a depression in the ground that's with these plastic things wrapped in a pond liner. We then can overflow into a leach pond, and then after a leach field there to the right, and then or a soak-away pit, and then only after that it goes into the street. And the building of the future, I think this is kind of what we've been talking about here, where we take the roof water, running into rainwater recycling, we take our gray water, and then the Australians will talk to you about black water and recycling and sewer mining. So we minimize, we go to approach a net zero application of water for buildings. We then can minimize the strain on the infrastructure with less sewer or less rainwater required for the building. So yeah, let's catch the rain. Why not? If you have any questions, you can call me later, but probably better off would be best if you check the ARCSA website if you want to find out more about rainwater, more about the progress we're making on codes, and if you want to meet a lot of very interesting people. So thank you very much.